And we are back. So talking about ions, we already labeled on your periodic table, so make sure your periodic table is out. We always said alkali metals, they normally form ions of +1. So that should be labeled above group 1 on your periodic table. Alkaline metals usually form ions with a +2 charge, meaning they lose 2 electrons. And what I also want you to do is label groups 13 and 14. So group 13 normally form ions with a +3 charge, meaning they lose 3 electrons. In group 14, those form charges of +4, so they lose 4 electrons. Okay, then going to the other side, group 18, we said those are the noble gases, those are unreactive, so those will not gain or lose any electrons, so they have a charge of 0. Then next to that, group 17, those halogens form ions with charges of -1, -1, meaning they gain 1 electron. Then next to that, group 16, ions in that group usually gain 2 electrons, so they have a charge of -2. And then group 15, those atoms, in order to form ions, usually gain 3 electrons, so they form ions with charges of -3. Okay, then there's a couple other things I want you to label. So those charges that we don't know are in groups 3 through 12. Okay, we don't know the charges of those metals in there, and specifically in there, those metals are called transition metals, since they're in the middle of the periodic table. And also, if you look down below those bottom 2 rows that were labeled the lanthanide and actinide series, another name for that is the inner transition metals, since they're inside the transition metals. So the bottom 2 rows are also called the inner transition metals. And one other thing I want you to label on your periodic table are the metalloids. Okay, so the metalloids are between the metals and nonmetals, so that means they have properties of both that are in between. So metals are good conductors, nonmetals are poor conductors, so metalloids are semiconductors, and these are useful especially in computers. Like one of the main components in computer chips is silicon. Okay, so all those metalloids are those elements that are directly touching that bold line, not just the corner, but all those that are directly touching the bold line. The only exception is aluminum. So aluminum is directly touching that bold line. However, aluminum is always classified as a metal. Okay, so now we're going to talk about how ionic bonds form. So here we're going to talk about how salt forms. So how an electron transfers from sodium to chlorine. Alright, so first off, a sodium atom. Every atom is neutral, so it has an equal number of protons as it does electrons. So since sodium, its atomic number is 11, it has 11 protons and 11 electrons. But what happens when it reacts with chlorine, it subtracts 1 electron, so now it does not have the same number of protons as electrons. So 11 protons and 10 electrons means the overall charge of the sodium ion, usually we refer to it as the sodium ion rather than the sodium cation. So it's referred to as Na+. So that's how we would refer to that, and if we were using the full nuclear notation, putting the mass number here, the atomic number down into the left, and then the charge always goes up and to the right as a superscript. And always, when writing the charge, the number goes first. So let's say instead here sodium had a charge of positive 2, we would write that as the superscript as 2 plus. Okay, so how this reaction works, we have a sodium atom. It loses an electron, so that's essentially one of the products, and we produce a sodium ion. And this makes sense. Now at the end we have 11 protons, 10 electrons, so that's what results in the positive 1 charge. Now that electron gets transferred to chlorine, so now we have the chlorine atom plus an electron, and we obtain the chloride, we call the chloride ion, which, since it's negatively charged, is classified as an anion. And this makes sense. The atom has the same number of protons and electrons. It is neutral. Then once we gain an electron, 17 protons, 18 electrons, that's where we get the negative charge from. So same thing if we were writing out the nuclear notation of this, the mass number, atomic number at the bottom, the symbol, and then the charge up here. Remember, and if there's a charge that's greater than 1, we would write that number first. Okay, then finally, we can see this violent reaction. Sodium, which can be cut simply with a knife, except you have to be very careful with it since it is extremely reactive with water. You put that into a flask of chlorine gas, and the reaction, if you can see here, is quite exothermic. It releases a lot of energy, and then the result, we get table salt, which are sodium, you can see here, sodium and chloride ions packed closely together. All right, that's all for now. See you next time.